Okay, this is my project, the climate control system. The title of the project is the CPSLO, CP Slow, the climate protecting system for long hours, the HSI.
Thank you, bro.
The goal of the project is to be a controllable and modular temperature system. However, it is very difficult to do. So far, here's what we've got. We have got adjustable temperature settings. You know how students want to be comfortable? Well, there you go. It's not focusing very well, but as you can see, you can set the temperature using this potentiometer, which has been very kindly placed in the middle of as many wires as possible. So I'm going to twist it, and you can see the set temperature adjusting as I go. Now another part of the project is the fan. So ideally, in an ideal world, however I do not have this working right now, is that this fan will activate in a way that is facing this humidity sensor right here, that will turn this humidity down to a desired point, which is displayed right here. Ideally you want 0% because dry is better.
One interception against Auburn, bro.
Now, it also has the current temperature displayed above. Now, you can see it is 71 degrees Fahrenheit in this building, in this room. Now, this system is toggleable, so let's say you don't want the control system micromanaging your temperature, we can turn it off using that button.
This one is the rivalry game, though.
And the off state is signified by this buzzer. You can hear it. That's the buzzer that signals it off. And when you want to turn it back on, just press this button.
But yeah.
And the system reactivates the potentiometers. Now let's say you have accessibility issues and you have trouble seeing. Well, this very not accessible potentiometer adjusts the brightness. So you can turn the brightness up, turn the brightness down.
Like he would never shut up.
However, I have it at the ideal state right there. That's the ideal state.
I mean, I wasn't even friends with them too.
Now,
wait, hold on, go back to the
here's something that's very cool about this particular project. You can see that I've set the temperature to above the current temperature. That means there should be a heater on, correct? Well, as you can see, the heater icon, the red, would ideally be linked up to a real heater. And I've also included an RGB LED to add aesthetics to my breadboard. The idea is the RGB is an essential part of the student experience, and having an adjustable LED, which is currently set to purple, which should really show up on the LED on the camera, but it is purple. You can kind of see it on the reflection. It is purple, and this purple is very peculiar. It's a very obscure color for colors to have.
My favorite is people who get dripped out just to
with that, that's a beautiful.
You know that guy on TikTok
that would activate and begin bringing the temperature up. And if I set the temperature below 71 degrees, so let's say I want it to be a freezing 29 degrees Fahrenheit in my room, then the AC will turn on, which is signified by that blue LED, which would ideally be linked up to a cooling AC system. Now that is wonderful. Now another one of my favorite things about this project is the emergency pull switch. So let's say you start a fire in your dorm, press this button right here, and it ideally the buzzer, which is very quiet at this very moment, goes on and starts an emergency sound siren. And ideally, however, due to the limitations of the computer, that should be displaying evacuate the building, yet it is not. And that is something that cannot be done with Arduino C++ with the hardware interrupts. And then afterwards, the system must be manually restarted, which means that a human person needs to come in and make sure that the system is well and alive and has not been affected by the fire. I actually just unplugged the wire, bro. I unplugged the wire. Where'd it go?
Oh. Oh.
Oh my god.
Damn, bro.
You're not. This is gonna get cut out of the video.
Yeah. He's wrong.
Okay.
I'm wrong.
So again, you press the emergency button and the siren goes off. You evacuate the building. Now the system is bricked, and that is on purpose. The computer is bricked on purpose because a manual reset is required. So a human inspector would come in and ensure that the structural integrity is okay, and they would reset the onboard computer, which will just set it back to the original state, no problem.
Yeah, Osiris right now.
And we're gonna put this up to a comfortable 70.
Oh, he's at Stanford.
80. We're gonna put it to a comfortable 80. And that is it for the toggleable and interactable aspects of the project. Now for the technical parts, as you can see, there are a lot of wires. I'm using a single analog pin to read the potentiometer. I'm using an insane amount of digital pins to read and write data to the LCD display, which is here, the LCD display, and also to read data and supply voltage to the temperature and humidity sensor, the DHT11 humidity and temperature sensor in the corner. I'm also using the breadboard supply module given to us in our Arduino kit to supply additional current to my system. I've got a active buzzer here. I've got multiple buttons littered throughout my project that activate multiple circuits that enable our items. I've got the fan, which should work, however, currently my system does not support it, as turning it on does affect the computer too much. I am utilizing potentiometers, adjustable potentiometers externally, so that human adjustment is very possible. I'm using LEDs to signify when certain circuits are enabled, to signify actual systems that could be activated in real world usage. However, they are not usable.
Yeah. Dude, you can do a whole lot.
And
dude, with the MP3 decoder that I have,
I will.
That's only like.
And that is it for my project. It cannot actually affect anything, however, it is very modular and usable. So, thank you for watching my YouTube video, and I'm very tired. Thank you.